Alright, sine, cosine, and tangent. You may have seen these buttons on your calculator and had no clue what they mean, but these are very important in showing us how to find the missing sides of a right triangle. And these are three types of names for trigonometry or trig ratios. And trigonometry is basically the study of triangles, and it uses the terms opposite and adjacent in relation to an acute angle of a triangle. So you're going to hear those words an awful lot: opposite, adjacent, and it's always in relation to the acute angle of a triangle. And you may think, well, geez, why do we need to do this? Or what's the advantage to knowing this? I already know Pythagorean theorem, isn't that enough? So to answer the why, you only need an acute angle measure and the length of one side. Remember, Pythagorean theorem requires two sides, and then you can find the other two. And later on, it can actually give us the angles if we know two of the sides. So these trig ratios really tell us a lot about a right triangle. And actually later on in trig, you'll learn how to do it without right triangles to find the missing sides or lengths, which I think is pretty cool. Now remember the words opposite and adjacent? Let's go ahead and draw a diagram to show when we would use those terms. So just draw a right triangle with me, and I'm going to label this A, B, and C. I know, real creative, right? And let's say that we were talking about in reference to angle B. So if we're talking about angle B right here, then this side right here would be adjacent to B, and this actually has to always be called, it doesn't matter what angle you're referring it to, it's the hypotenuse. Remember, it's a really long word for a really long side. And just think, the sun shines on the sea, remember that? So the sun shines on the sea. So the longest side, or the side opposite the right angle, is always the hypotenuse. So yes, for angle B, this is also adjacent to it, but we're not going to think of it that way. This is the adjacent side because that's the hypotenuse. So I'm going to call this adjacent to B, to angle B. And if that side's adjacent to angle B, then what's opposite of angle B? All the way over here. So we're going to call this side over here as opposite to angle B. And that's basically the whole premise for trig, or the whole terminology. We just use adjacent, opposite, and hypotenuse. Alright, and how do we remember all this? Well, there's a easy way, I think. This is your memory tool. It's called SOHCAHTOA. So write that down. It's SOHCAHTOA. And SOHCAHTOA is an acronym that stands for sine is the opposite, so OPP. I'm just going to abbreviate since we've already defined those words over here, opposite and adjacent and hypotenuse. So I'm going to abbreviate all of those words as I write this. So sine opposite over hypotenuse. So basically these are ratios it's forming. And then this is cosine is adjacent over hypotenuse. And cosine is COS on your calculator, but the whole word is COSINE. Adjacent, I'm just going to call ADJ. And hypotenuse HYP. And now we've already used sine and cosine. Do you remember the other one? It's tangent. And tangent is, O stands for opposite, A is adjacent. So we're going to write tangent, A-N. It's just T-A-N in your calculator, but the whole word is tangent, G-E-N-T. And then opposite, and then adjacent. All right, and these words help us to figure out the ratio for sine, cosine, and tangent, because they're all different ratios. All right, now that we've learned that acronym, let's go ahead and try to apply it. So example 1, find the sine, cosine, and tangent of angle U. All right, I need you to draw this triangle with me. We're going to draw triangle UNC. I know, I did that on purpose. So UNC, Tar Heels. And on UNC, we're going to make the C as our right angle there. And we want the sine, cosine, and tangent of angle U. All right, and fill in these side measurements. Side UC is 10, CN is 24, and side UN is 26. And I'm going to start with sine. So sine of angle U equals, and I'm going to look up to my chart. So is sine is opposite over hypotenuse. This is giving me the ratio. So opposite's on top, hypotenuse is on the bottom. And I'm going to write that out so you can see it. So it's opposite over hypotenuse. Then I'm going to write sine of U. Well, tell you what, we'll just write it next to here. So opposite over hypotenuse. So the opposite to U is over here. So it's 24. So 24 goes on top. And then the hypotenuse is the side, the longest side. And if it helps, you can just label that the hypotenuse, so you don't have to think about it. So the hypotenuse of our longest side is going to be 26. So I'm going to fill in 26 for the hypotenuse. Now, is that reduced? Nah, not yet. So just divide by 2 since they're both even, and we get 12 over 13. All right, so one down, we figured out the sine. Now we're on to cosine. And for cosine, remember was SOHCAHTOA. I'll go back up there for a second. Cosine stands for adjacent over hypotenuse, the CA, adjacent over hypotenuse. So I'm going to write that relationship over here. So cosine of U equals, and what's adjacent to U? Well, this and this, but we don't call the hypotenuse the adjacent, remember? So the other adjacent side is the 10. I think adjacent means next to or next door. So there's angle U, the 10 is next door to it. So I'm going to write adjacent over hypotenuse, which is 10 over, what's that 10 going to be over? Well, what's my hypotenuse? 26. So 10 over 26, and those are even numbers, so divide them both by 2, and what do we get? 5/13. All right, 2 down. We've got sine and cosine out of the way. Now we're on to tangent. So I'm going to look up here at tangent. Remember, tangent stands for, it's TOA, so opposite over adjacent. So I'm going to write tangent of U equals TOA, opposite over adjacent. And notice tangent is the only one that doesn't use the hypotenuse. All right, so what's my opposite to U? It's over here, it's 24. So 24 goes on top. And then what's adjacent to U? 10. 10 is next to U. So 10 goes on the bottom. And then divide those both by 2, and we get 12 over 5. All right, now we have all three ratios, sine, cosine, and tangent, so we've knocked out example 1. All right, now that we know about the ratios, let's talk about the angle measurements. To find the sine, cosine, or tangent of an angle measure, first change your mode in your calculator from radian to degree. All right, now the mode button is this one right here. It's right next to the second button. So you'll just press that mode button there, and the third one down. Third one down is going to give you a setting saying radian and degree. So you just press the right arrow and then enter onto degree. And degree will be bolded in whenever you select it. So that's our first step. We want to make sure it's in degree mode. It's like you're telling your calculator what language to use. It needs to be speaking degrees because you're talking about an angle measurement. Alright, so let's do an example with that. Find the value of tangent of 76 degrees. Now tangent is, you'll see the string of sine, cosine, and tangent right here on your calculator. And tangent's going to be the third one, or the one all the way on the right. This one right here. So press the tangent button and then type in 76 and then enter. And after you do that, it's going to give you a big long decimal. Alright, I've rounded that to 4 decimal places, and I came up with 4.0108. Alright, I'm going to try one more with you. Let's do sine of 42 degrees. Sine of 42 degrees. So go ahead and type that one in. And remember, sine is all the way on the left there. So I'm going to press sine of 42 and then enter. And I got 0.6691 if I round to 4 decimal places. Alright, so now we know how to use the degree mode in our calculator. Well, let's apply it, okay? Because we're doing this all for a reason, right? We want to find some unknown stuff. So let's go ahead and think about maybe a wheelchair ramp. Let's say we know how high it goes up and we know the angle of incline, but we don't know how long the ramp is. Looks like this guy could have used a wheelchair ramp, huh? There, that's better. So we're talking about this ramp. So I'm going to draw a picture to represent this. So the angle the wheelchair ramp makes with the ground is 10 degrees. Well, I'm going to draw the ground. Remember, when in doubt, draw it out. So draw the ground, and there's some nice little grass on our ground. Okay, getting carried away. The ramp is going to go up. There's the ramp. It's going up 10 degrees. So that's 10 degrees. I'm going to label that angle because it says 10 degrees with the ground. And then I know it's making a right triangle. It says it rises 8 feet. So the rise is going to be how much straight up it goes. And we want to find out how long the ramp is. Well, this is our ramp right here. So we don't know the length of our ramp. Alright, well, let's do a little bit of trig and see if we can figure this out. So we have our picture, we know what it looks like, we know our degree measure, we know a side, and now we just need to find the length of the ramp. And this would be excellent for a builder to know, like if they know that the door is 8 feet above the ground and they have a 10-degree incline, how much ramp are they going to need to build or construct? So this would be excellent for somebody to figure out with actually going on the site and measuring. Okay? Alright, here we go. So what do I have here? I know 10 degrees and I know 8. So which one of my ratios, and I'm going to write out SOHCAHTOA. So SOHCAHTOA. Which one of these ratios is going to give me a known measurement with an unknown. And that's the key. It's a known with an unknown. And not all of these are going to work. So if I have 10 degrees, which one's going to work? Well, I have the known measurements, my opposite of 10. And then what I want to know is the hypotenuse. So this is the opposite of 10, and this is the hypotenuse. So which one uses opposite and hypotenuse? Well, look at your acronyms. So katoa. Opposite over hypotenuse is O and H, so that's sine. So I'm going to use sine, and I'm going to write my ratio down. So it's going to be sine of 10 degrees equals opposite over hypotenuse. And that means that the sine of 10 degrees, I gotta give this guy the boot. Sorry, buddy. Wasn't working for you anyway, right? So sine of 10 degrees equals 8 over my hypotenuse is, I don't know, so that's my x. So I'm just going to solve a proportion. And nothing's on the bottom, so I can put 1 on the bottom. So x times sine of 10, if I cross multiply, and 8 times 1 is just 8. And now I want to solve for x, so I'm multiplying by sine of 10, so the inverse is dividing. All right, and now it's just in your calculator. You just get your calculator out and do 8 divided by sine of 10. Make sure your calculator's in degree mode. And I got about, I'm going to use the about symbol there, 46.1 feet. All right, and that's how we can apply trig ratios to find out real-world questions. All right. And somebody could have benefited from trig, that's for sure.